Prove that sin A minus cos A plus 1 divided by sin A plus cos A minus 1 equals 1 by ck minus tan A. So here we have to prove sin A minus cos A plus 1 divided by sin A plus cos A minus 1 equals ck minus equals 1 by ck minus tan A. So at first, in order to prove this, we are taking left hand side of the equation, that is sin A by minus cos A plus 1 divided by sin A plus cos A minus 1. So what we are going to prove? We are going to prove this LHS of this equation equal to RHS, that is 1 by ck minus tan A. For proving that, at first note, the terms of RHS are in ck and tan A, but LHS is in sin A and cos A. So in order to get the terms in ck minus tan A, what we have to do? We have to divide each and every term with cos A. Okay? Why we are dividing each term with cos A? We will get ck and tan A terms in this LHS. So we are dividing each and every term with cos A. Then we will get sin A by cos A minus cos A by cos A plus 1 by cos A whole divided by sin A by cos A plus cos A by cos A minus 1 by cos A. Now, what is sin A by cos A? That is tan A. Cos A by cos A is 1. 1 by cos A gives ck. Sin A by cos A, tan A. Cos A by cos A 1 minus 1 by cos A ck. So, we get all our terms in sec and tan. Okay. If we get all our terms in sec and tan, let us observe we have to reach here, that is 1 by ck minus tan A. It is not easy for us to reach ck minus tan A here. So what we are going to do next is we are multiplying and dividing ck minus tan A. That is, it is very difficult to reach to our RHS. So what we are going to do? We are multiplying and dividing ck minus tan A. So it will become easy to reach to the RHS of this equation. Okay. So what we need as our RHS? 1 by ck minus tan A. So we have a 1 by ck minus tan A in the denominator. So what we are going to do? We are retaining that term here. Okay. That is 1 by ck minus tan A here. And we are not touching it. We are not touching that term anymore. Next, what we have to do? We have to cancel each and every term here so that it will becomes 1. And 1 by ck minus tan A into 1 will gives our RHS. Okay. So we have to cancel each and every term here. For that, at first we have our denominator here, that is tan A minus ck plus 1. We are not taking that. We are not multiplying with that, with the ck minus tan A, because we have to retain that term. Now, what we are going to do? We are going to simplify our numerator. That is, we have ck plus tan A minus 1 into ck minus tan A here. And we are multiplying numerator which is ck minus tan A. Now, here ck plus tan A, here ck minus tan A. On multiplying, we know that a plus b into a minus b will give a square minus b square. So, we will get sec square a minus tan square a here. Now, minus 1 into ck minus tan A will give minus of ck minus tan A. Okay. That is, minus 1 into ck minus tan A will give minus of ck minus tan A. So we get our numerator like this. Now, what is sec square x minus tan square x? That is 1. That is 1 here. Now, taking negative inside, we will get minus ck plus tan A. So, we get our numerator like that. That is 1 minus ck plus tan A. We can also rewrite our denominator as 1. Okay. Here we have 1, 1 minus ck plus tan A. Just to rearrange our denominator to get this term. On cancelling these two, we will get 1 by ck minus tan A, which is equal to our RHS. So what we have done so far, at first we take our LHS and we make each and every term in terms of ck and tan A on dividing cos A. In the next step, we have multiplied and divided ck minus tan A to the numerator and denominator and taken the denominator 1 by ck minus tan A outside, and we cancel each and every term after that in order to get our RHS. Okay.